Welcome back. This is your last lesson for this unit. It's called the intermediate value theorem. And this one's actually a pretty easy one and it's kind of fun. So let's get started. The intermediate value theorem for continuous functions. And the fact that our functions are continuous is going to end up being important. So imagine that we have some kind of random function. Don't draw this quite yet. So imagine I have a random function. Maybe it goes, who knows, something like that. And I'm going to focus in on just one piece of it. So I'm going to ignore this first part here. I'm just going to start at some point, ignore this part here. I'm going to start at another point. So in your notes, what you might want to draw, instead of the whole function, we're just going to focus in on one piece, maybe from, looks like this. But you know, it keeps going in both directions. We're just going to focus in on one specific section of it. And from that section, we're going to say this section starts at an x value of a, and it ends this section of it on an x value of b. So we're focusing in on our function just from an x value of a to an x value of b. And you can imagine this could be like from 1 to 5, if you like. It can be pretty much anything, but that's the idea, is we're focusing in on one particular section of a function. Well, in that case, my y value for that section of the function, if this is a, my y value at that point, this would be f of a. Plug a into my function, and that's how I talk about the y value at a is called f of a. And the y value for down here for b would be f of b. So whatever value, plug b into my function or pull it off my graph, the y value is going to be f of b. So what the intermediate value theorem says is that at some point along my function, from a to b, I am guaranteed to have all the y values between f of a and f of b somewhere on this function. So somewhere as I trace along here, I'm going to have all the y values from f of a to f of b. And a could be f of a could be greater than f of b, it could be less than f of b, we don't really care. What we do usually have is a being less than b, a being to the left of b when we're talking about it. So for example, this could be, f of a could be something like 100. Got 100 up here on my graph, and this could be something like maybe 10. So what this is saying, what the intermediate value theorem is saying, is as I trace my function from a to b, I pass through all the values between 100 and 10. So if I was going to ask you, is 74.65 somewhere on this interval? You'd be able to say, yes, I could find some x value to match to a 74.5 y value. I don't know exactly what that is, but the fact that I go from 100 down to 10 means at some point I have to pass through this value of 74.65. So in math speak, here's what it looks like. So if my function f is continuous, and it actually is important that my function is continuous because that means it can't jump over any values. So if my function f is continuous from an x value of a to an x value of b, then every value between the y value when I have x equals a and the y value when x equals b exists at some point in the interval from a to b, including a and b. So if you need to pause your video now to write that down, draw yourself the picture, go ahead, pause, and then we're going to see how that actually works, how that actually applies. So here we have a table of values for a, again, important that it's continuous function, meaning it doesn't jump any y values between any values that we see on here. So it says, question number 1, on the interval from 0 to 9, so x equals 0, here we are, x equals 0, all the way to x equals 9. So in this case, we're looking at the whole table. What is the minimum number of zeros? Remember that a 0 is when y equals 0 or when we're crossing the x-axis. So to figure that out, we kind of got to envision in our head what's going on in each of these intervals that we've got. So we're going all the way from 0 to 9, but we're going to look at them as we jump from one number to the next number to the next number and see if we can figure out if y equals 0 is guaranteed to be on that interval. So as x goes from 0 to 3, f of x goes from 1 to negative 5. So it starts above the x-axis at 1 and goes down to negative 5. So we know we have all the values on this interval between 1 and negative 5. Now is 0 between 1 and negative 5? Remember, these are our y values. Yes, there would be a 0 in here. To get from 1 to negative 5, I have to pass through 0 at some point. Then I go from 3 to 4. My x values go from 3 to 4. My y values go from negative 5 to 3. So here I am below the x-axis at negative 5, and it goes up, 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 up to 3. So are we guaranteed to have a y value of 0 between negative 5 and 3? Again, the answer is yes. 0 is between negative 5 and 3. Then we go from x value of 4 to x value of 8. We go from a y value of 3 to a y value of 7. So if we go from 3 to 7, are we guaranteed to go through 0? Is 0 between 3 and 7? No, it's not. So we would say not guaranteed to have a 0 on here at all. And then from 7 to negative 1, as we go x from 8 to 9, 7 to negative 1, I'm going back down again, and 0 is again between 7 and negative 1. So I've got 1, 2, 3 possible places where I am passing through the value of y equals 0. So what is the minimum number of zeros? We have at least 3. There are at least 3 zeros. So there might be more than 3 zeros, but we have at least 3 because of the intermediate value theorem. So we take a look at number 2 now. It asks us, on the interval from 4 to 9, so now we're not doing the whole table, we're just starting from 4 to 9. So when you look at a question, don't assume you're using the whole table. From 4 to 9, what is the fewest possible times f of x equals 1? So now we're looking for, this is again, remember, f of x is your y value. So we're looking at where is this value equal to 1. So again, let's take a look at each of my intervals. So as x goes from 4 to 8, going from 3 to 7 on y, and 1 is not between 3 and 7, so I'm not guaranteed that I have at least one value of y equals 1 on this interval. Then I go from 8 to 9, my y values go from 7 to negative 1, so in this case 1 is between 7 and negative 1. We have to go through 1 to get to negative 1, so we only have one guaranteed 0 on this interval. There might be more over here, but we don't really care about this section. We only want to go from 4 to 9. So there is one guaranteed f of x equals 1 on the interval from 7 to negative 1. Okay, so for this one, we're going on the interval from 0 to 4. So that puts us here 0 all the way to 4. We only care about this section here. And it asks, must there be a value of x for which f of x equals 2? Explain. So is there a place where we have to go through the y value of 2, see what's going on here? So when we go from 0 to 3, we're going from a y value from 1 to negative 5. 2 is not between 1 and negative 5, so no guarantees in here. But when we go from 3 to 4, we go from negative 5 to 3. 2 is between negative 5 and 3. So I've got a 2 in between these two values. So there's no way, if my function is continuous, to get from negative 5 to 3 without passing through 2. I'm going up from negative 5 up to 3. So let's see how we write that when they ask us to explain. What does an explanation look like? So to explain, I would write something like yes, because must there be? Yes. On the interval from 3, x is greater than 3 and less than equal to 4, because I found it between the x values of 3 and 4. F of x equals 2 because of the intermediate value theorem, and I'm just going to abbreviate it with IVT. So this is showing that you found it between 3 and 4. So this is showing that you actually do know what you're talking about, and you remember the reason why is the intermediate value theorem. That's my justification. And we're going to keep using this intermediate value theorem all through the course. So later on, it might be harder to remember. Right now, it's pretty much the only reason we've got. All right, one more question. On the interval from 4 to 8, so just from here to here, could there be a value of x for which f of x equals negative 2? Explain. So we're not asking must there be, but could it be? Is it possible that there could be a value of x for which f of x equals -2? So sometimes these help to think of in a graphical way. So if I had the point 4, 3, if I'm thinking, okay, I'm starting at the point 4, 3 and going to the point 8, 7. So I've done something up here would be 8, 7 on my graph. Gone up a little bit. I have no idea what it actually looks like in between these 2 points. I could go straight there, but I could also go way up, down, back. As long as it's continuous, got no guarantee of what happens in between. It does have to be a function, though, can't go back on itself. So am I guaranteed that f of x equals -2, which would be maybe somewhere down here? Not guaranteed, because I could go straight up. I can't say there must be, but there could be. It's possible that I dip down low enough to get to -2 in between these two values. So if I had to justify must there be, no, I don't know if there must be. It's not guaranteed, but there could be. It's possible that it goes that low. So again, how do I write that? How do I explain that? So I'm going to write, yes, it is possible f of x equals -2, but it is not guaranteed. Don't know for sure. Possible, not guaranteed. All right, that's it for this lesson. Good luck with your homework and your mastery quiz.